Well, cool. It's 5 past, so gonna, I guess, get started. So this kind of meetup I booked, 90 minutes. I don't think we're gonna necessarily use all the time. The main chunk of today is going to be community spotlight. So we have started to have Gilad kind of present, and then so roughly 30 to 40 minutes ish there, depending on how things go. And then after that, going to present a few of the new features we kind of rolled out and pushed out at in the last, I guess, 2 months or so. And then if people want to stick around, we can chat. But otherwise, by no means you have to stick around. But open mic for any time kind of left. So super excited to introduce Gilad. I think in terms of, I think since you're all here, I'm preaching to the choir a little bit. Hamilton has definitely its way of getting you to write and organize, and so which case I think there's some of you feel quite passionate about it, and then also what we've been trying to work on is how do you go from development to production, and then how do you iterate. And so excited to hear a little bit about what Gilad has been doing with Hamilton in that regard. And so I think some of the things that he's thinking about are pretty interesting and exciting to me, that are broadly applicable to whatever you're using Hamilton. Gilad, with that intro, I'll let you share screen and take it away.
Thank you so much. Okay. Just give me a sign if you see my screen.
Yep, it's good.
Okay. So, hi everyone. Excited to be here. This is, for me, it's a pretty big deal because I've been working on this project for a couple of years, I would say, and especially the last couple of months. And I'm really happy about the results. And a big part of it is thanks to Hamilton as the basis of this framework that I'm going to present today. So let's dive in. A little bit about myself. I'm a chief data scientist at Viridian Analytics. It's a startup company in Israel that does climate tech. We gather information, we analyze it, we do data science and forecasting on climate data, and we distribute that to customers. I have 10 years plus of experience, hands-on experience in data science. And I have a natural tendency to ask how things ought to be done in different domains. It can be landscape photography, personal growth. Now it's coffee brewing, and especially data science and AI. And I had this question: how am I supposed to build iteratively my code base, my project in data science and AI? And I never got a really good answer for that. So today what I'm going to show is a culmination of my personal research in the past couple of years, and especially the last couple of months. And in some sense, this is like, for me, this is like the end of a long-standing research, but also a beginning of a new type of research on how to make what I'm going to show you today better. Okay, so we're going to go over motivation for this process, some pain points in today's solutions, my suggested solution, a demo, and then some future plans. Okay, so the motivation for this project is to build a workflow for data science and AI, focused on the developer experience. It needs to be optimal with regards to performance metrics, or as optimal as the developer can make it. It needs to be flexible and robust in the sense that it needs to be maintainable by myself as like the past, present, and future self, and other team members. It needs to be easily extensible, adding new implementations, new ideas, and it should always be, in some sense, production ready. And the user experience should be smooth and intuitive in some sense. So the current pain points for what I've been experiencing and experimenting with, I started with the naive code base, which is kind of like Jupyter notebooks turned into Python modules and somehow manually defining a workflow, using Jupyter mainly as a testing ground, and that creates a lot of scattered notebooks. There wasn't, for me, a clear workflow or methodology to move from Jupyter to production code. There was a lot of code duplication. And there was what some people call usually training serving skew. I call it dev prod skew. It's like I develop something and then in production, it looks different. And if I want to develop something new or to improve it, extend it, it requires a lot of back and forth. So then I moved to DAG-based frameworks. And I should say there are a lot of amazing frameworks. Kedro is the main one I used. There's also Metaflow, ZenML, Airflow, etc. These are sometimes called orchestrators. And yeah, there are a lot of those frameworks available today. One of the main problems I had with them is kind of a technical aspect, but it's actually pretty big, is that you need to manually define, I call it like wiring and rewiring, your pipelines and DAGs. When you have this property, when you need to manually define the nodes and then the pipelines, if you want to make any change there, you need to kind of look around and find where you wired everything and how you need to rewire it again and again. That was for me just a deal breaker. I couldn't do that anymore after a couple of tries, and then that's how I kind of stumbled into Hamilton, and I realized the ingenuity of the way this framework works, and we'll talk about that. Also, these frameworks, many of them are based on Python modules. And then when I wanted to move into Jupyter notebooks or to have some exploration and interactivity, it was a very difficult experience. It was kind of like a one-way street for me. And then there's also, that's a small note, but there was also a lot of YAML files included, which I personally don't like because of the lack of flexibility compared to Python. Okay. One other thing is that I haven't found an intuitive way to perform hyperparameter optimization on a project scale. I could do it for a certain model, a certain part of my project, but it was difficult for me to take large parts or parts from different hierarchies and find the best combination of those hyperparameters in some sense. So that made me fidget a lot. I was tinkering with hyperparameters, whether it's which model to use, whether to do feature selection or not to do feature selection, whether I should take this test set or that. I just tinkered with it until I got a good result, which is not a good practice. So it creates overfitting on the test set, not in the trivial way of training a model on that test set, but in the sense of the hyperparameters can overfit the test set. And then when I change the random seed of the train test split, everything breaks down. And what I thought was getting me towards the right goal turned out to be not true. So I had enough of it, and I wanted to find a better solution. And here are some guiding principles that I've gathered for a solution. So the solution should enable interactivity and exploration. It should have a responsive workflow. I can, try different things, try new libraries, even if I don't know exactly how to write everything. Have a interactive, responsive workflow. If there are any problems, bugs in my workflow, I should be able to debug them in a friendly way. And if I have a new idea or a new experiment I want to make, For example, I want to try a new LLM, or I want to add a re-ranking step, or I just want to see how this model performs with more trees. So I should be able to easily craft new experiments and test new ideas. And one of the main pillars here is to support empiric decision making. So instead of tinkering, as I mentioned earlier, if I can make everything or anything a hyperparameter, whether it's the number of trees in my model, an algorithm choice, even a full pre-processing step or a whole workflow, I can choose to toggle it on and off or change the value that it takes. And I can easily swap between these choices and sweep, as they say in the world of hyperparameter optimization, that is testing different combinations of hyperparameters. Then I can make experimentation as a foundation for decision-making in my project. So instead of manually trying different things and then just hard coding my decisions in the code, I can just craft as many experiments that I want and then run a sweep and see what are the best performing hyperparameters. And here I use hyperparameters in a very, very general sense. Again, anything can be a hyperparameter. And we should have development production sync in the sense that if I change something in one place, one area of my workflow, of my DAG, it needs to propagate to the whole workflow. I need to be able to configure my execution easily. I will show that in the next couple of slides. And deploying my new implementations or chosen hyperparameters should be very easy as one click. And the last thing is the way I usually, or personally, the way I think or like to code or approach difficult or complex problems is to see them visually and have hierarchies built into them. So I can look at the full picture of this project and see it visually. And then if I want to zoom into a certain part of it, I can do it and see the code there or configurations there. And I only want to see what's relevant for my context in this moment, whether it's local or global. And in that sense, this is an implementation detail, but I would need to have a responsive UI that supports this. Okay, so now we're moving on to the actual solution that I'm suggesting. So in this solution, we need to have DAGs, and this is why we're here in this Hamilton meetup. And alongside the DAGs, we need configurations or hyperparameters. So this is an example of a real image from a code that I'm going to show you. This is a real DAG, and these are the configurations that are associated with this DAG. Interesting. I think this is configurations from another one, but we'll see this one as well. And I would like to be able to kind of wrap these two together into what I call a node or a hypernode. When I do this, when I wrap them together, and these configurations are associated directly with this DAG, they actually get instantiated and sent as inputs to this DAG. And I bind these two together, I can execute in a very easy way different configurations of this DAG. So in order to make this, I chose Hamilton as the backbone for this project. And this is due to its flexibility and just a bunch of features that are just incredible and enable things that I thought were very far away in the past, but now I can have things like tracking and distributed execution and debugging and visual inspection in one line of code. And to handle the configuration space, I wanted to use Hydra, actually, if anyone knows this package from Meta. But unfortunately, I realized that this package currently is not fit for this specific task that I'm trying to solve here. So I actually built a package called Hypester. This is actually, it's funny, it's a package I built about 4 years ago. It was pretty different. It had similar goals, but I repurposed it to allow for this solution. So we have Hypester for configurations, we have Hamilton for DAGs, and we have hypernodes for the framework that binds these together. Any questions so far? Okay, yes.
Hi, Gilad. Thanks for giving us this presentation. I just have a quick question. What didn't work in Hydra for you? Because we are also thinking about using Hydra and just drawing on your experience.
Well, I can be just pretty straightforward. I tried to make it work for 2 weeks, and I couldn't. And that's way too long. Maybe it is possible. It was just the syntax or the API is just, for me, it was just too complicated. I couldn't get it to work. I don't have a better answer than that currently. Yeah.
Great, thanks.
When you'll see the API syntax interface for Hypester, you'll understand the difference, I think, if you've seen Hydra. Any other questions? Okay. So, as I mentioned, Hamilton, dynamic DAG framework, flexibility here is key. Hypester, swappable hierarchical configuration framework, written in pure Python. And hypernodes are the glue that binds these two together. And the combination of configurations and DAGs allows for executions of DAGs based on instantiated configurations. It also comes with interactive UI. I will show you this, and plugin for tracking, hyperparameter optimization, and deployment. This is all really, really, really new. Like, I built these packages in the past couple of weeks. So everything is very alpha, what I'm going to show you. So there's much more to come. I'm very excited about this, and I'm planning to put a lot of effort into improving this. So let's, I'm going to go over a workflow. I took RAG question answering because that's what's popular today. This can also work on any ML problem or LLM-based projects, time series, etc. I do have a repo in case you want to kind of look at it as I go. I can send it in the chat if that helps. Let's do it now. Okay. Okay, so this is the main DAG for our project. And I encourage you to imagine how you would feel if you entered a team or a new project in your team. And this is the first thing you would see. You would see this DAG and these configuration knobs. These are interactive. I just put a screenshot here, but they're interactive. And when you select the hyperparameters here, you can see how the DAG changes, if it changes, and you can execute this workflow. So for me, first of all, this is great because this helps me ground in where I'm at in this project. Okay, so here we get texts, we take a chunker and we split them into chunks, and then we have a ranker and a query, and we get the top chunks that are relevant to the query, and then we add these chunks as context to the query, and we send them to the LLM with its configuration and a system prompt to get a response. And here we can choose different types of chunking strategies. We can choose different rankers, different LLMs. Mini is GPT-4o Mini, etc. So my emphasis today is not really the code itself, but I will show you the code. And for those who are new to Hamilton, we have pretty much one function per node. So we have the texts node, the text chunks, top K chunks, etc. And this is like a toy example. I didn't really try to find the best way to do this. It was really to get the point through. And this is the syntax or API for Hypester. And I tried to make it as minimal as I could. Like, what is the minimal amount of words you need to use or code you need to use to define a hyperparameter space? So here you have it. This is very similar to Optuna. If you know their API, trial.suggest. And it's also pretty similar to Streamlit in some sense. So if you want a chunker or like a chunking strategy, so you can select paragraph, semantics, text, and you have a default. You can define it as a dictionary where you put the key here and then the value. And so you can say haiku, mini, sonnet, etc. And you can also have nested configurations. So this is a dictionary and it has a temperature. Temperature can be a number and the default is 0. So if you access this parameter, hyperparameter, you can do llm config.temperature equals this. Any questions about this? Thierry, did you want to say something?
No, I just shared the link for Optuna. I think it's very cool. What you're doing is very clear. Like, I think when code is elegant and easy to read, usually it means that the stuff is good. So,
okay.
Congrats.
Great. Thank you. And now we have the DAG, we have the configuration, and then we want to bind them together. So we import hypernode. In the hypernode, we just say the name of the node, the DAG modules, and the hyperparameter configuration function. We can save it to disk. This is currently the implementation. It's just local. And then we get it creates Python modules, the DAG, the HP config, and some metadata. And then if we want to run or execute these, we can just load the node from disk, from the folder. We instantiate the inputs with our selections. So I selected LLM model to be Sonnet. If I left it empty, it would just take the default. And I decided to override the top K for the ranker. This returns only the top 3 chunks of text that are relevant to the query. Once I instantiated the inputs, I can execute the DAG. I can tell it to return the LLM response as the final var variable, and then have the inputs be the one I instantiated. Okay, let's do a live demo. And I want to show you in this demo how nice it is to do everything I showed in Jupyter Notebook. Do you see my screen big enough? Is it the font? Is it large enough?
Let's say probably a little larger. You could.
Okay, is this better?
Yes.
Okay. So we start with basic naming, like this is a RAG question answering node. I define a folder. And here I have the configuration. This is what I showed you before, the Hypester configuration. And you know what? Let's just restart it and run it. So I just run this cell. It's just a function. And here I can define my selections. And this is funny. This never happened to me. This is why you're not supposed to demo live. Okay. Okay, cool. So selections. I select this. I run it, and then yeah, this is so interesting. It's so slow. Yeah, the gods of Jupyter know that I'm demoing live right now.
If you had a demo that worked perfectly, I wouldn't trust it. So
Okay. That is so funny. 19 seconds. Okay. This usually runs in less than a second. So bear with me. So here we have the inputs. And as expected, we have a dictionary with the selected hyperparameters. So these are the instantiated hyperparameters. Here we have kind of like the space of possible hyperparameters. And here it's an instantiation of it. And a nice trick that I like to do is to add these, like this dictionary, into the globals dictionary of Jupyter. And when I do this, I can just ask for texts, path, and I have it available here. And you'll see in a second why this is really nice. And that's it for the configurations. We go to the DAG portion. We need to load the Jupyter Magic, some display configurations, and this is my DAG. I can run it. And it actually, I decided to not just define it, but also execute this DAG using the Jupyter Magic with the inputs that I've instantiated earlier. So this DAG that I showed you before is actually running now. And I can see it here. And what's really nice about this is that I can just explore and see what are what's the LLM response? What is the query? And here, what's nice again is that, let's say something is not working really well, or I want to incrementally build this workflow. So I can just start with the smallest DAG of one node, and then see that it works. If it works, I can just add another part and run it, see that it works. And then if something doesn't work here, I can just take it off the DAG. And because I have all the inputs available in my global space, I can really just run this, and this works. So except for the return part. So I can do this and just see what comes up here. And once I figure out what's wrong, if there's a bug or anything, I can just compile it back into the function and bring it back into the DAG. And this is something for me, like I'm showing you this kind of like pretty quickly, but this for me is life-changing in my workflow. It's amazing in theory, in the team, you're great for doing this. Because I always had difficulties, as I mentioned earlier, taking kind of production code and debugging it and then changing it and putting it back into production. And this workflow for me is almost ideal, I would say. Okay, so bringing them back together. Okay, we have the DAG again. I can run it. And now I have the hypernode. As I mentioned, I can just define the name. The name was RAG QA. I save it. And I can see it here. The hypser configuration, the DAG, everything is available. And now I can run this here in this notebook, this node, or I can run it in any other notebook. So from a DAG, it turns into a node or a hypernode. So I can just treat it as a node. And this to me is also critical. I had to kind of adjust my thinking to hierarchical thinking. Even if this is really complex, this is a, I don't know, pretty complex workflow, I can look at it as one node that receives a query and maybe even just that, just a query, and returns an answer. So now I can compact this into a node that I can use in other DAGs. And I'm going to show you how I did this in this example. But already here, if you've noticed, we have already a node that is a DAG. So the ranker is actually a hypernode. The code for the ranker is not written here. It's just calling on a hypernode and running it. So I hope this is not blowing your minds right now. I hope this is manageable, because this is the, yeah, please.
Yeah, I mean, so the hypernode is, I mean, effectively just a wrapping of a Hamilton DAG with some way to configure and instantiate it. Is that?
Exactly. And this allows for this hierarchical implementation. So here I see the workflow of the DAG, and then I want to see, okay, so how does this ranker work? Great question. So we can go into the notebook for the ranker. I decided to implement it with scikit-learn because it's like tribute to TF-IDF, long forgotten algorithm or vectorizer. And I decided to implement the ranking algorithm with TF-IDF. So I have the same structure here, almost the same, with the name. It's called sklearn ranker. I could have 3 more different implementations for ranking. I could have sentence transformers. I could have whatever I want as separate notebooks and define them as hyperparameters when I select the ranker type. So I will show you the notebook in a minute, but just so you understand, this is a hyperparameter, which ranker to use. So here I just implemented one, but I could have implemented another one. So sentence transformers ranker. And I could just open a new notebook, build this implementation there. It's decoupled from this current DAG. And I can reuse it in other projects if I want. So I go into this, I define my configs. This has different configurations, top K, chunks, n-gram range, analyzer, whatever the TF-IDF vectorizer needs. And then I also have the DAG portion, but I do need to add one more thing, which is the upstream inputs. Whenever I'm working on a notebook or a node that is part of a bigger DAG, I need to make sure it has its inputs. So here I have the configurations for the TF-IDF vectorizer, but I do also need the query and the text chunks, etc. So when I run this, I can get the upstream inputs. Let me show you the keys. So I get the, well, this is not important, but I get the text chunks and the query from the parent DAG. And this plus my hyperparameters are what I need, the inputs that I need for my DAG. So if I wanted to change the parent DAG, let's say I wanted to use a different chunking strategy, I would just say semantic. And then I would run this. This won't work because I didn't implement this, but let's say I implemented semantic chunking, then I would get the relevant text chunks according to this. And one great use case for this is, let's say I'm working on something that's really heavy and I want to get just a sample of my kind of my upstream nodes. So I could just do sample toy or whatever, and then I would get the relevant inputs, but just as a sample instead of the full data set or whatever I'm working on. So this is configurable. You can just leave it on the default. You can change it, and then you have all the relevant inputs that you need. And then you define your DAG, you run it, and it's the same thing. You save it as a hypernode, and you can run it from anywhere. And specifically, we run it in this RAG question answering DAG, but again, we can run it from anywhere else. Yeah, so this is the code.
Yeah, so I guess the key point is the rather than, so the ranker could be a Hamilton DAG driver in some frame, but with the hypernode, you're wrapping the two. Yeah.
Exactly. Yeah. And they interact nicely. Like when we do it this way, the code for the DAG is much more straightforward and elegant, and the code for the configs makes much more sense. We don't confuse these two. We don't couple these two. And it allows for a more generic DAG. So this expects a hypernode. I can put whatever I want here as long as I configured it properly. I hope this makes sense.
Yeah. I think this is really cool. The thing that it's like kind of blowing my mind is the hypernode notion that abstracts away the complexity of stringing a bunch of DAGs together. Whereas oftentimes, like the basic Hamilton, it's like, okay, you've got this module, this module, this module. You see sort of all this complexity. That
Exactly.
Really what you want is black boxes, and this is sort of a way to wrap that complexity
Exactly.
in a way that proves these sort of specific interfaces as black boxes, which is another approach that makes it so you're only thinking about that one sort of path that you're trying to optimize over, and then configuring the rest, right? And then you can sort of build more and more on top of it. Yeah, that makes a lot of sense to me. I think that's really cool. I think there are also sort of as you develop this more, there are more ways that we could make it so you could like flip on and off visualization for the hypernode as you fix it and like other stuff like that. So I think that's super cool.
Yeah. One thing I did was difficult for me was the sub-DAG notation in Hamilton, because it just exploded my DAG. It just, in one moment, it just added all this complexity from the ranker in this example. Imagine you would have this added to this node, to this DAG. It creates a lot of complexity. And for me, I really need to have only the relevant variables or nodes in my current context and not have all at once.
Yeah.
Okay.
I like that sort of black boxing quite a bit. I think there are things we could do in Hamilton to make that a little more natural too, to make it so that you could like visualizations where you could flip on and off certain sub DAGs and stuff like that. I think would help this too. Cool.
Okay, great. So now let's move into some other parts. I'm not going to go over the whole notebook, but I just built a workflow that I actually, in retrospect, I could have done it in Hamilton instead of a notebook. That makes more sense. But this notebook shows how to convert a hypernode into an MLflow model. For those of you who don't know, MLflow allows for tracking experiments, and also it has a models section where you can define kind of like an easy way to define an API for a model and deploy it to production in different environments like Azure, AWS, etc. I use it in my workplace, and it's really nice. And I just tried to see how I can take this RAG QA, this DAG, this hypernode, and turn it into a MLflow model. So again, we're taking this whole DAG, this whole complexity, and turning it into something that is available via an API. And I just wanted to experiment and see how easy it is, and it's really easy. So the only thing I need to define is I need to define the node that I want from the where it's located. I can define some selections and overrides for production. For example, I want to use Sonnet, Anthropic Sonnet, Claude Sonnet in production, and I don't know, change the path for the text files or something like that. I can do it here. Oh, this is just a test, but and I built this really easy class that just takes a hypernode, turns it into an MLflow model, and you can just go over it in the repo and see what I did here. And you can just, just input an example and get an answer from this MLflow model. And this could be just deployed with one line of CLI code. So this is really powerful. And this is something I always wanted in some sense. Like now, when I have this, if I change something here in the sklearn ranker, that is a node in a bigger DAG, I change this to say, I don't know, +1. It doesn't make sense, but whatever. I save it, save the hypernode, and I run this again. I can ship it to production with this changed code or implementation or configuration. I can just change the model that I want to use and just ship it to production. And it's all synced kind of both ways. Okay. Yeah, so just to show you this, I can go into my models here. You can see the PDF model. I don't know why I called it PDF model, but it's here. Okay, let's go back to the presentation. Am I good on time, Stefan?
I was gonna say, I mean, yeah, 5-10 minutes. That's fine. Yeah, I'm gonna have to bounce at 10:30 because I realize I have a call to take. So, but
Okay.
Thierry and Elijah will be on.
Cool. So we're using Jupyter Notebooks as an IDE, our main IDE. It allows for responsive, debuggable experience. We bundle the DAGs and configs into hypernodes and save them as Python modules. And we can deploy them as models to MLflow or any other framework that we want. It's pretty easy. And now updates are propagated throughout the project, which is great. I already did this. I showed you how to add, how I added kind of like a ranker here with its own hyperparameters, and it's great. And now let's talk about evaluations, tracking, hyperparameter optimization. So now we're going to take kind of like a zoom out once more. And now our RAG question answering DAG turns into a node here. And in this new DAG, we wanted to test different, like what are the optimal hyperparameters for this whole project. Like if I want to deploy a good RAG system, I want to test out different models, LLM models, different rankers, different hyperparameters. So I can define a data frame of user queries divided into questions and answers, like a ground truth. I can send the questions to the to different RAG instantiated RAG pipelines or DAGs, and then compare the results to the real answers and get an accuracy score. And this DAG has different hyperparameters. It has just the path for the queries and for the texts. And here I'm going to show you, I'm going to use the MLflow adapter from Hamilton, which is incredible. And now we're going to move to the UI. So now that we have this is a different way of viewing the DAG. We have the user queries, and yeah, this is the same DAG as I showed you before. It's just in Streamlit, and we have all the hyperparameters here, and you can even tell me what you want to test out. So we can do haiku, and yeah, let's go crazy. Okay, this actually didn't work. Okay, it's an int. Okay, So now I can just execute this.
Actually,
This
can you
hypernode?
can you zoom in just a little?
Oh, yeah. Is this better?
Yeah, great.
Okay. So now I executed this DAG with these configurations. It's still running. And in a couple of seconds, it's going to say that it ran successfully, hopefully. And what's nice about it is because we're using the ML flow tracker from Hamilton. Okay, so it ran successfully, and this is the full hierarchical configurations. You have rag QA, ln config, the ranker, hyperparameters. Everything is written here, and you can already see it in MLflow. So I ran it through Streamlit, and now I can see this run. I can see its accuracy. I can see all its hyperparameters, and I can compare it to other runs with different hyperparameters. So it seems like Haiku is doing worse than GPT-4o Mini in this example. Okay, and a very kind of trivial next step is to do hyperparameter optimization like automatically. I didn't get the chance to really implement it yet, but this is like a really small example to show you how it's with just kind of like 4 or 5 lines of code, you can make this happen. You just define different options here, you get their combinations, and then you instantiate the node, run the DAG, and that's it. It's all registered into MLflow or whatever framework you want to work with, and you're kind of done. If you want to use Optuna, you can plug it into Optuna. I'm going to add these like more specific plugins in the future. So we're in the summary section. Are there any questions so far? Okay.
Maybe like from a developer perspective, were there any friction points between your Hypester library and the MLflow package, or like it just wires everything through the Hamilton integration?
This is completely Hamilton.
Okay,
Yeah.
cool. I'm happy.
Oh, there was something small. I'll show it to you later. Yeah. Okay. So to sum everything up, by separating the configurations from the DAGs, we get something that's really useful when we bind them together. Again, with using a hypernode, we get this hierarchical workflow that is visual, interactive, responsive, production ready. Really, like I went through all the kind of guiding principles that I mentioned earlier. So the interactivity and exploration, when we use Jupyter Notebooks, we get this interactivity. Hamilton-based debugging in Jupyter is wonderful. That's my experience so far. Adding new hyperparameters and nodes is a breeze. You just add one line into the Hypester function and you're done. Now that we have this, anything can be a hyperparameter using this combination, and you have an interactive UI for testing different configurations. You can easily find the optimal hyperparameters for your performance metrics, and soon we'll have sweeps and Optuna if the search space is too large. Everything is synced in your notebooks and in production. Yeah. And this could be also easily extended to any framework, Bento-ML, Fast API, Gradio. And everything is hierarchical, as I mentioned, interactive, visual, etc. Okay. Okay, some caveats. Hypester and Hypernodes are in early alpha stage. Please do not use them in production. The code is not 100% behind the scenes, but what I showed you today is real code. there is a learning curve to learn Hamilton and to learn these packages or frameworks, and also this methodology. I do think it pays off. I'm not very objective, but yeah, this is my experience so far. And coding in Jupyter Notebooks can sometimes be buggy and unexpected. That was my experience in the past couple of weeks, specifically with these workflows. When we run DAGs within DAGs, that's where sometimes things start to be weird and unexpected. Looking forward, I want to mainly improve the code base. That's my main concern, to make it kind of more robust and improve the methodology. I would love to get help from the community. If there are open source maintainers here that would like to help, I would appreciate it a lot. I'm going to work on much more features and tighter integrations and release some blogs, article, video tutorials. And that's it. Any questions or comments, responses for the presentation?
If you do find bugs with the DAGs within DAGs, stuff within Jupyter Notebooks, obviously no, but just like let us know, open up issues. Those are all things that should support, and obviously that we should support, and obviously their edge cases. So happy to help out. I think this is super cool. I love how you took it, like a lot of what we did with Hamilton was some low level pieces, and they worked up from the like mental model of how things should work, how people should work with it. I really like how you took the how people should work with it and took your use case and then worked down to match it with the things that we built. So I'm like, it's just super exciting and inspiring to see new sort of ways of working with the stuff that we built. So thank you for this.
Thank you. Yeah. Thank you, Stefan, and everyone. If you want to connect, you can send me a message on Slack in the Hamilton community, or go to my GitHub that I posted in the chat. Otherwise, thank you so much. See you in the next talks.
Yep. Thanks, Glad. Yeah, super exciting. I think we were talking about this a few months ago, so great to see a combination of this. And I think I've had other conversations with people in the community. So Roy, you're also thinking about experiments and kind of tracking, somewhat related, not necessarily the same. But I think there's definitely an interest of like, how do you parameterize a Hamilton DAG? And so this is where I think Hypernode definitely is probably the most advanced that I've seen anyone kind of position things. But well, cool.